Two coins, A and B, have initial velocity shown. So a quarter is going to the right at 2 feet per second, and a dime is going to the left at 3 feet per second, just before they collide at point O. And so their line of impact is at 30 degrees from x prime. They both have weights, and they slide on a smooth surface. And what are their speeds just after impact? So we're going to start by rotating the axis. So we'll call this x, and we'll call this y. And that's important because the force will be normal because it's a surface contact surface, so the force will be normal. So there'll be no force in the y direction, which simplifies that, because if there's no force in the y direction, there's no impulse in the y direction. Therefore, the integral of f dt is 0, and the velocities in the y direction will be unchanged due to the impact. So the first thing we want to do is rotate the line of axis and find the 2 velocity and the 3 velocity in components. So if I have 2 to the right like that, it's going to have a component in the x direction parallel to that, and in the y direction parallel to that. So if this is the positive x and this is the positive y, this is going to be a positive x and a positive y. And so the velocity, this is the velocity of the quarter. So the x component of that is going to be 2 cosine 60. That's 60 degrees there. And the y component is going to be 2 sine 60. So the y component of the initial velocity quarter is 1.73, and the x component is 1. So now if we do the velocity of the dime, velocity of the dime, initially it is in, now we're rotating that, so we need to find the y component there and the x component there. So this angle here is 30, and so this is 3 cosine 30 equals the y component, which is negative 2.6, because that's the positive y, so this is in the negative y. And then this is in the negative x also. So the x is equal to 3 sine 30, which is equal to negative 1.5. So in the impact, momentum is going to be conserved. So let's look at the impact in the x direction. That's the rotated x direction. So conservation momentum is going to be the mass of the quarter times the velocity of the quarter in the x direction initially, plus the mass of the dime, the velocity of the dime in the x direction initially. And that is equal to the mass of the quarter, the velocity of the quarter in the x direction finally, and the mass of the dime, the velocity of the dime in the x direction final. So putting in, we're going to multiply by g to get rid of, so we can use the weights here. And so we get mass of the quarter, or the weight of the quarter, is 0.0132. The velocity of the quarter is 1, plus the mass of the dime, 0.0066, and the velocity of the dime is negative 1.5. And the mass of the quarter is again 0.0132, and the velocity final we don't know. So that's the velocity q, x final. And the mass of the dime is 0.0066, velocity of the dime, and the x final. Combining these, we get 0.0033 equals 0.0132 VQXF plus 0.0066 VDXF. Now looking at the impact, we know that E is equal to 0.625. So E, in this case, is the velocity of the dime final, not velocity of the quarter final, minus velocity of the dime final, divided by velocity of the dime initial minus velocity of the quarter initial. And so 0.65 is equal to velocity of the quarter and the x final minus velocity of the dime and the x final over negative 1.5 minus 1. So that simplifies to negative 1.625 equals velocity of the quarter and the x final minus velocity of the dime and the x final. So we can solve this and then using this equation and this equation we can solve this, and the velocity of the quarter of the x final equals negative 3.372 feet per second. And the velocity of the dime final in the x equals 1.25 feet per second. Now in the y direction, the velocity of the two are unchanged because, as we said, the force in the y direction is 0. So the impulse is 0. And so then, so you could say v unchanged. So the velocity of the quarter then, final, is equal to negative 0.32372 in the I plus 1.73 in the J, and the velocity of the dime final is equal to 1.25 in the I minus 2.6 in the J. So that's the velocities we found here in the x and with the y that we found originally. So then the speed of the quarter is equal to the square root 0.372 squared plus 1.73 squared, which equals 1.77 feet per second, and the speed of the dime is the square root of 1.25 squared plus 2.6 squared, which is 2.88 feet squared.